Jorge, Camilo, Diaz, Garcia z CEMEX Global R&D, który opowie, jak narzędzia cyfrowe mogą wspierać drogę do neutralności pod względem emisyjności CO2. Jorge, the floor is yours. Tak, Ela będzie. Zaraz Ela będzie po naszym panelu, więc zmieniliśmy tylko kolejność.
Great, thank you very much. Thank you for the invitation. And okay, there is this. I have the challenge to get into an application related to sustainability between BIM, let's say, construction, sustainability, no? And the idea is that we try to show you some examples of some digital tools, right, that we have developed, okay, internally, but with the idea to support customers or different stakeholders how to reach the carbon neutrality, sorry, that everybody is aiming to have. Okay, first of all, a bit of presentation of the company, CEMEX. Maybe some of you have heard about it in Poland here, but this is a global company that basically produces different building materials like cement, ready-mix, aggregates, and different urban solutions like admixtures or construction products. One of the key activities of the company, which is in the building, in the team that I am belonging to, is the research and development. We're based in Switzerland. We have the different teams in Switzerland and Mexico. Just to know that the CEMEX is a global company. It's a Mexican company, let's say, its origins, but it's today a global company. And coming back to the research and development, it's not only about materials, okay? Because we can imagine that we have in the lab a lot of equipment, microscopes, or different tools, of course. They exist there to create new binders, new cements, new materials, new ways of industrialization. This is quite important. But one of the things that we have been following since, let's say, more or less 10 years, it's been what are the different technologies that are driving the new construction. No? The so-called digital construction is, of course, in that front. This is why we are also belonging to Building Smart since, I don't remember now, 3-4 years. And we're joining Building Smart International and some of the local chapters. And of course, one of the key levers we have today are piloting decarbonization technologies. I know everybody wants to have our planet like me, personally, optimizing the use of our resources. Nevertheless, it's not that easy to change technology from one day to the other. And decarbonizing our industry is a challenge. But I think, and I believe we are in the right path, or at least we have an idea how to do it. In the case of the industry, okay, let's think about cement and concrete industry. There is globally an inventory of a bit more about 2.8, something like that, gigatons of CO2 that are released every year, let's say, or are up to now. And if we keep going globally with the population growth and the business as usual, we will reach by 2050 3.8, okay? Now, the question is always, okay, how do we get to net zero? There is a path today already, agreed by different companies around the world and different specialists, and there are different levers, okay? They are all there. Like, for example, I will explain some of them more in detail, but there is today an agreement, at least globally, in the Cement and Concrete, Global Cement and Concrete Association, the GCCA. What are the levers that the industry needs to do in order to get to the net zero? Let's think about the following. All of them have different impact, let's say, and different ways to do it. The very first one I would like to comment is what we can do at the cement plant or at our production facilities, okay? There are three main topics. The first one is how to lower the quantity or the use of clinker inside concrete. Maybe for the ones who doesn't know, cement, okay, this powder is made out of an artificial stone that is called clinker. And to produce this artificial stone, we need to heat over 1,500 Celsius degrees limestone, okay? And this limestone is transformed into this clinker, new material. But the heating, for heating, we need a lot of energy, okay? And that's why one way is to say, okay, how can we use the less of clinker inside our cement? And this is one lever that, okay, in the global it will give 11% of the reduction of emissions. The second one is the carbon capture and carbon utilization, which is, okay, how do we get back the CO2 that is released to the atmosphere into the process, into the same process, okay? And these are quite interesting and promising, okay, technologies that are piloted today. And the third one is maybe most common one is energy decarbonization. I give here one example. Like today we have a real pilot. This is a picture of real pilot in the plant in Spain, where we have we are concentrating with these heliostats in the bottom part to one receiver, the solar energy, and being able to heat over 1,200, 300 Celsius degrees. And this is quite important because concentrating the solar energy is not new, but being able to transform that energy into heat up to that quantity is really new. We have partnered with some startups in Switzerland, and it has been a very promising technology that today we already produce, let's say, the first solar clinker in the world. Now, another thing we can do that is not at the cement plant. Okay, remember, in the cement plant we produce the clinker, we powder, we mill, and then we send this cement to the ready mix plant, okay, to the construction site where there is the mixing process. So in the mixing process we can do also some things, and this is more on the materials design for the engineers. They're like engineers need to reach certain strength. This is like a recipe, okay? We mix with certain quantities to reach certain performance. But today we are, okay, let's say all over the world there is still a space to optimize. Perhaps we are using too much cement in the concrete mixes. The other point it is, okay, what can we do at the concrete production site? There are also things that can be done, and these are different initiatives going in that way. Okay, now these let's say initiatives that we can do at the cement sites and also at the concrete sites, it boils down into the CO2 of the concrete. When we hear about the carbon footprint of concrete, it is because we are considering all the CO2 that has been emitted at the production sites, okay? So everything flows in a data, in a value, that is precisely the one that we would like, and we are reaching, let's say, sending to the BIM model. At the construction site, okay, where, let's say, supposedly we are using BIM or the company or the project itself is using BIM, the project needs basically information at the end of the day. And we have seen a lot of examples today. But the way the information is used is not only when we deliver the concrete, for example, and the builder would like to know, okay, what is the CO2, exact CO2 of my concrete? Okay, we can send it that, and this is what is here in these moving arrows. But there is another effect, okay, which is very high in the design of the building already. Perhaps our structural design is not the most optimized one, okay? So that means that we have a lot of buildings today that they are over-designed. And this is quite a lot of material that is not needed, okay? Unfortunately, in some places, it's on the contrary, no? It's under-designed, and we have catastrophes, basically, no? That's why this is a little bit sensitive topic, no? It's not, if we have good rules, we can make it the project more efficient. That means that we can influence during the design phase, where BIM is today highly used, let's say. A lot of software vendors have very good solutions to help designers how to define a more optimized solution for the specific building or bridge or whatever infrastructure asset. Now, there is another level that is more naturally. It is called recarbonation. Basically, concrete, cement and concrete, once it is in the air, having contact with the air, the CO2, it absorbs naturally CO2, okay? But that depends on the area that is exposed. We have, for example, here, maybe I'm pretty sure there are some beams, columns that are not exposed to the air, but maybe some concrete that is exposed to the air in the street. That concrete, as we speak, is absorbing CO2 every day, a bit. And this counts, okay? And there is a way, of course, to make these calculations. Of course, what we aim is that to transfer all this information to the final user, let's say, or as the as-built model, going to the digital twin. Okay, so in the future, you will know exactly how much concrete is going to be is in the structure, how much CO2 was used for producing the materials, and even how much CO2 can be absorbed by this structure during the following years. Now, let's go a bit in concrete. No? One important thing about concrete is, I brought these two pictures, okay? And maybe some of you have seen concrete in the streets or at the job sites. And which of the two are concrete, okay? And basically, because some people only see it in fresh state and some others only when it's in hardened state. So both are concrete. Unfortunately today, inside the BIM, let's say, environment, we have seen that it's not well described. This is quite important to do. Now, fortunately, today we have important norms or regulations. We have heard about the EPDs, or the Environmental Product Declarations. Those are documents, quite important documents, that explains and shows the real facts, real global warming potential of any product. And when we talk about construction materials, there is a norm how to do it. And there is also a norm specifically for concrete, which is the EN 16757. Now, what is considered into the CO2 footprint? The first thing is the materials that are used to produce concrete. I already explained, okay, some of them about the cement. We need aggregates, we need also chemicals and others. Nevertheless, we need to transport those raw materials to the factory, okay? And to the factory we use, okay, transportation that is usually using fossil fuels, and this needs to be in consideration. The third one is during manufacturing. At the concrete plant, we also use fuels, we also use ancillary materials, we also use a lot of energy, and so on, no? And even produce waste, no? And during production, there is kind of waste that is also being accounted here. Additionally, we need to transport. Something to mention is that in the vocabulary of in the glossary of the EPDs, it's important to count from the what is called cradle to gate, which is up to the door of the materials producer's plant. What is the CO2 footprint, right? Because after that, the material supplier cannot control what is onwards, okay, downstream. So this is more on the hands of the builder, let's say. We can, of course, account for the transport to the building site, but inside the building site, we have to account, or the builder, let's say, have to account for different topics, no? How much steel it uses, how much materials used for casting, for curing concrete, for all the tools that the workers use, etc. No? All these counts, all the fuel, energy that is used during construction, the cranes, the energy for the cranes, the energy for the vibrators, etc. All this type of equipment. If we are able to have all this information, of course, then the analysis will be complete, will be in what is called life cycle analysis. In our case, let's say our internal solution, we have created some tools in BIM, in our BIM system, leveraging two topics, very important. One is this calculator of CO2 for our material. And this is, I mean, I'm showing just an example of our case, but globally, all the industry is moving towards having EPDs, let's say, or having public information, transparent information, certified information about the CO2 of the materials. Just a quick reminder that the environmental product declarations, they are renovated every 4 or 5 years because, of course, during the production processes, if we implement new decarbonization technologies, okay, we will have lower CO2 during the time. So we need to update this information. We can also report cradle to gate with options to A4. These are just technicality from the norm. If we include the transport to the job site, or if we can influence or we can give, for example, construction services, so we could potentially do that. But usually, material supplier is giving information cradle to gate, meaning up to the door of the plant. Now, what is important here, what we are advocating is to properly characterize concrete, right? Which is one of the, I would say, missing parts in the BIM world. And what do we mean by that? Okay, here is just an example of a project we work in the past, is a house. But the important thing is, okay, we say from this model, let's extract basically what is concrete, okay? This is what we can influence. We would like to influence, and we could potentially influence in other parts of the models, like for example, thermal. Depending on the type of material of concrete, we can influence the type of windows, the type of ceiling, etc., or even the insulation system. So doing a simple, let's say, extraction of all the concrete parts of this model, either they are concrete floors or concrete walls, we then can work on the parameterization. And this is what is basically an ad hoc, let's say, a solution. But the intention here is to give all the parameters that the concrete has between fresh concrete and hardened concrete, and add the right information to the model. Because what we have experienced, at least, is that is today a bit of incomplete information. So the specialists that are going to make calculations for a structural design or for thermal design or any other type of analysis, they lack of information. So imagine, even if you have the model, you don't have all the information. Therefore, you need to go to the building material supplier or to other engineers, ask for information, and then introduce that information manually, etc. No? So, okay, and this is not, let's say, so automated. So with this process, what we are proposing is let's characterize, parameterize completely, and this can be used, let's say, worldwide somehow, and import and give the right parameterization to the building or to the structure. This is an example of a tool that, let's say, has been created in our platform. It's a plugin where we let's say, upload the different values of the CO2, extract the materials, the quantities. You see there are a lot of blanks, because usually the models only have strength, and but this is not enough. Then we add the different new parameters to the concrete. We complete the values, including the CO2, the right CO2 value that is, let's say, calculated according to the norm. So in the process of making this parameterization, we are making our analysis more accurate. That's the idea. The more transparent we are, the more accurate also the calculation can be. And this let's say, analysis help us also to design, for example, targets, to reach targets. How much CO2 per square meter are we aiming to have in this building? And what are the different scenarios that I can have? This is quite important. Here we have also an additional tool, for example, to calculate the CO2 from the distance to the concrete, from the concrete plant to the job site. And basically at the end, in a, let's say, I would say very easy way or fast, we can have calculation of how much CO2 can I have comparing with the baseline, okay, with the standard materials that are produced with standard cement, not with the special cements or with special aggregates, etc. And here this gives us the possibility to have a more a better analysis, let's say. Okay, this is almost finalizing my presentation. I want to mention that we are part of the Reincarnate project with Mostostal and the Polish Green Building Council, with the aim of, okay, let's try to maximize the analysis of life cycle for a building and try to understand how we can take advantage of the materials quality, how the circularity can be implemented, how, for example, the electronic delivery tickets can be implemented in a regular base for any project. And of course, with the aim of reduce the CO2 footprint of the building. Hopefully this project is going to deliver quite interesting use cases of application of these tools. Just to finalize, benefits, okay, I don't need to convince you about the benefits of digital tools, but in the context of creating lower carbon buildings or infrastructure, of course we need to speed the analysis, and this is time of taking decisions. What is the right product we want to use? The second point is that we need to leverage the certified information into the building, okay? That is coming from the norms, let's say, and building materials. Of course, it's important for understanding the different value propositions. We cannot build better buildings with the same type of material as has been used for 100 years, okay? We need to use the new materials, okay? But how do we understand these new materials work? Okay, this is what this type of tools help to understand how to do it. And okay, of course, facilitates all this process of integrating the data into the models.